Hi friends, welcome back to my channel JN Academy. I am Devansh Pathak. So today we are going to start our new science topic, which is class 8 science chapter number 6, combustion and flame. So in this video you will learn uh, how fire takes place, what are the reasons for it, what are the chemical changes that occur in this, and we are going to talk about the structure of candle, flame, matchstick, and etc. So we have many topics to cover, so let's start. So first we are going to start with the introduction. Now, combustion is a chemical process in which a substance reacts with oxygen to give off heat and light. So as you have seen that whenever your mother burns a stove, it produces fire. So this is known as combustion, in which the heat reacts with oxygen and give off both heat and light. Now, for example, we have burning of wood. So burning of wood doesn't produce flame, but it produces both heat and light, so it is combustible. And one more example is petroleum. It also gives off heat and light and also produces flame. Now we are going to talk about combustible and non-combustible substance. So here we also have the diagram that shows us that the fire takes fuel, oxygen and heat, and in result it produces exhaust or CO2, heat and light. Now, combustible substances. Substances which can easily catch fire are combustible substances such as paper, coal, wood, petrol, etc. But the substances that do not readily catch fire are known as non-combustible substances such as sand, water, glass, etc. So you have noticed that whenever we uh, burn sand, it doesn't burns, and it either do not produces heat or light, so it is a non-combustible substance. But items such as paper gives off heat and light, so it is a combustible substance. So in combustion the flame doesn't matter, only the heat and light. If the heat and light is given off, it is a combustible substance. Now now we have the structure of fire. So a fire needs three things, three elements to catch. First, oxygen, heat and fuel. So you have seen that whenever someone goes for a campfire, he first collect woods as a fuel, oxygen is present in the air, and as a heat he produces spark from any object or from stones, and and only due to this the wood catches fire. So these are the three basic elements for it. So if we remove each or any of these elements, the fire will not take place. Now, history of wood and candle flame. So first we are going to talk about what is fuel. Any substance which upon combustive combustion produces a usable amount of energy is known as a fuel. For example, we have fossil fuels, biogas, nuclear energy, and many more. So, as you have learned in the previous chapter of class 8 science, chapter number 5, which is coal and petroleum. So, in this chapter, we have learned about what are fossil fuels, what is biogas, and many other. So these are our fuels as they burn very easily and they produce a usable amount of energy, a usable amount. For example, paper also burn, but we can't use it for cooking. So it doesn't produce a usable amount of energy. That's why it is not known as a fuel. Fuels can either be solid or liquid or gas, depending on their state. For example, in solid we have wood, coal, charcoal, etc. In liquids we have petroleum, or in gas we have LPG, CNG, and biogas. So, on the basis of their occurrence, it can either be natural or artificial. Now we are going to learn how fire extinguisher works. First, fire control. Fire can be controlled by removing any of the three factors of combustion, as I told you. That if we remove any from the fuel, oxygen, or the ignition temperature, we are going to talk about ignition temperature further, it will not take place. And in fire extinguishers, we have CO2 or the carbon dioxide gas, which is heavier than oxygen, and it works as a blanket on the oxygen and do not let the oxygen to penetrate with the fire, and it slows down the fire very easily. And fire extinguishers are used mostly when there are electrical appliances or oil fire, just because if we use water is a good conductor of electricity, and this can harm the people. And if we use water on oils, oil is lighter than water, so it will float on water and will burn continuously. So the role of fire extinguishers is to cut off the supply of oxygen or bring down the temperature of fuel or both. Next, ignition temperature. The lowest temperature at which a combustible substance catches fire or heated in air is known as its ignition temperature. So, as I told you, that ignition temperature is the lowest temperature on which any kind of fuel or any item can catch fire. For example, the ignition temperature of diesel, LPG, acetone, methane, etc. is very low. But in some cases like coal, charcoal, wood, the ignition temperature is very high. So the substances which have very low ignition temperature or can be easily catch fire with a flame is known as are known as inflammable substances. So fire. Fire is the result of a chemical combustion reaction between oxygen and some sort of fuel, as I told. Now, now the fire produces flame also. So now we are going to talk about flame. How long a fire lasts depends on how much fuel and oxygen are available. Now we are going to start with the structure of candle flame. Fire triangle. As I told you before, that fire triangle has three elements, and if we cut any of these three elements, it will slow down the fire or will not make the fire to take place. Next, flame. So as you can see here in this graph, we have a wax candle which is burning. Now, flame is a visible and gaseous part of fire. Flame is the visible and gaseous part of fire. What we see as the flame is the light energy which is released due to combustion of fuel. Now, what happens that the carbon particles uh, here gets produced in air, and these particles burn and produce flame. So only when only when these particles are produced, the flame can take place. For example, in charcoal, this smoke doesn't produce, so it do not take flame. But in petroleum, it produces unburned carbon particles. Sorry, it produces carbon particles that burn and produce flame. So now here we have the structure. So first we have the hottest part, which is you can lightly see is the non-visible part. So it is the hottest part which is blue in color. Next we have moderately hot, which is yellow or nearly orange, and the least hot is the middle part, which is filled with unburned wax vapors. So the outer zone is the hottest part because it is the result of complete combustion. It gets complete oxygen to burn. But in the middle zone, there is partial combustion. There is not much enough oxygen. And the innermost part is the least hot part because only unburned wax vapors are present there. So whenever vapors produced from any kind of fuel, the flame takes place. Now we have the structure of flame. So the combustion is the outermost zone is the hottest among the all three zones is the blue in color and due to complete combustion. It is the non-luminous part of the flame that I told you earlier. The middle zone of the candle is moderately hot and is yellow in color. The partial combustion of fuel takes place. It is the bright part of flame. So this part is the visible part and it is a bright part of flame that we see. The innermost zone is the least hot and is black in color. So this is due to the presence of unburnt carbon. Sorry, it is due to the presence of unburnt wax vapors. So you can do an experiment with the help of your parents. First, take a glass tube and then put its mouth in the center of the candle where the unburned vapors are present, and then from the other end you take a lighter and light it, and you will see that the glass tube will burn. Now how this takes place, the unburned wax vapors goes there and it burns slowly and it produces flame. Now unburned carbon particles, carbons like fuel, like wood, coal, candle, petroleum release unburned carbon particles. These fine particles are dangerous pollutions that cause respiratory disease such as asthma. So these particles are not good for health. Now, as you can see here, we have again the structure of flame. So the above the carbon particles ignite and become incandescent, the initial form of carbon particles in the center, and flame heat vaporize into molecules of hydrogen and carbon in the least hot zone of the candle flame. So now we are going to talk about smoke. Smoke is an example of solid unburned carbon particles dispersed in the air. So all these unburned carbon particles uh, we see are in the form of smoke. The black color of smoke is due to the presence of unburned carbon particles in the smoke. Now, now the second structure is matchstick. So now we are going to talk about how a matchstick works. The types of combustion. So first we are going to talk about what are types of combustion. The type of combustion in which heat and light are released in a very short span of time is known as rapid condu- is known as rapid combustion. But the type of combustion in which these substances catch fire on their own without the application of heat is termed as spontaneous combustion. So in the spontaneous, so in the rapid combustion, the fuel releases heat and light in a very short span of time and very fast, but it do not last for much time. For example, we have the combustion of LPG. If we release, for example, LPG gas, some amount of LPG gas, and then burn it, it will burn very fast, very rapidly, and it will then finally it will close. But in the spontaneous combustion, the fire gets carry on for a long period of time, and the fire gets catch on their own. For example, in forest fires, the lightning takes place on the trees, and this produces flames, and these burns the forest, and this is known as forest fire. We have many more examples. Now we are going to talk about working of matchstick. The main component of the bulb of a matchstick is red phosphorus, which turns on white phosphorus when heated. So, first I am going to tell you about the history of matchstick. More than 5,000 years ago, small pieces of pine wood were dipped in the sulfur and were used as a matchstick in ancient Egypt. But it was very harmful for them and it was not also easily available. So, after a long span of time, a mixture of anatomy trisulfide and potassium chloride with white phosphorus with some glue and starch was applied on the head of a match with a suitable wood, and whenever this match was against a rough surface, white phosphorus gets ignited due to the friction. But these days, the head of the safety match contains only anatomy, trisulfide, and potassium chloride, and the surface on which it is rubbed was then powdered by the powder glass and some red phosphorus. So as you can see here in this figure, we have the powder glass and red phosphorus applied on the side of the matchsticks where we rough it. So the rubbing surface has powder with glass and a little bit of red phosphorus, which is much less dangerous. Now, some red phosphorus gets converted into white phosphorus after heating, and it produces enough heat to burn the potassium chlorate in the matchstick and produce enough heat to ignite anatomy trisulfide and start the combustion. So this is how a matchstick works. So now next we are going to talk about the caloric value. Now first we are going to talk about what is ideal fuel. So our ideal fuel must be cheap, easy available and ready to use. It must have a higher caloric value, which we are going to talk about next. It does not produce harmful gases or any residues behind that to pollute the environment. But as a disappointment, we don't have any kind of fuel that matches all these precautions. So we don't have any kind of ideal fuel. Now, the caloric value and efficiency of fuel. The amount of heat produced by the complete combustion of 1 kg of any kind of fuel is known as caloric value. The caloric value of the fuel is expressed in a unit known as kilojoule per kg or kj/kg. Efficiency is the proportion of energy released by a fuel combustion process which is converted into some useful work. And caloric value is directly proportional to its efficiency. If the value is high, the efficiency would also be high, means it will last for a long span of time. If the value is low, the efficiency will also be low. So as you can see here, we have a graph that shows us about the caloric value that you can see in your NCRT textbook. So the lowest starts with the cow dung and it then further goes, and the fuel that has most amount of caloric value is hydrogen that produces 1,50,000 kilojoule per kg. That's why it is used in rockets, because it produces so much energy and enough to be used in these aircrafts. Now, pollution, harmful products from burning of fuel. The burning of fuels like wood, coal, and petroleum products release unburned carbon particles that I told you in the form of smoke in the air, which causes respiratory problems like asthma. Now, incomplete combustion of fuel produces a very poisonous gas called carbon monoxide. The burning of fuel releases carbon dioxide in the air in the environment, which causes global warming and reduces the amount of oxygen that we take in. So, carbon dioxide is very important as the plants take it in and do their process, and then finally they produce food in the form of carbohydrates and oxygen that we take in. But the excess of anything is not good, and the same is here. If the carbon dioxide will be excess in the air, it will cause global warming. So our surroundings will get hotter and hotter, and this will disbalance the uh, temperature cycle of Earth. Now, co-immersion. Carbon monoxide is a poisonous gas that I told you, which is produced by incomplete combustion of fuels. It is dangerous to burn a coal in closed room, as the carbon monoxide produced can kill people sleeping in that room. Okay. So now we have global warming, the most important topic for our surroundings. The rise of an average temperature of Earth's atmosphere due to the release of carbon dioxide on combustion of fuels is termed as global warming. And the melting of polar ice caps or change in rainfall pattern are the consequences of global warming. So as you can see here, these are the 10 indicators of a warming world. So global warming is a very big threat to us as the temperature is increasing day by day. So as you can see here, so due to this temperature, the sea ice melts, the glaciers decrease, and the snow cover also decreases. And due to this, the snow melts and forms water, and the sea level rises. The sea surface temperature also rises due to hot temperature. Ocean heat content also rises, and the temperature of land is also increasing day by day. The temperature over oceans is also increasing, and the humidity due to this is also increasing. And the most important, the troposphere, which is near the Earth's surface, is also increasing at a very high rate. So we must prevent these situations and help our surroundings to prevent these threats. Now, acid rain. Acid rain is a very big threat. Acid rain is caused by emulsions of sulfuric dioxide and nitrogen oxide, which reacts with water molecules in the atmosphere to produce acid. So, as you can see here in this figure, the sulfuric the sulfur dioxide and the nitrogen oxide is getting from these different laboratories and factories, and these then immerse, and then they come in the form of rain, and these come in the form of acid rains. So acid rains are very harmful as they affect on plants, lands, aquatic animals, and the infrastructure of earth. And the most common example of it is Taj Mahal, which is getting dull day by day due to this acid rain. Now, CNG. CNG is the cleaner fuel, as the use of diesel and petrol as fuel in automobiles is replaced by CNG, which is the compressed natural gas, because it is less polluting and a cleaner fuel and is easily available. It is low in cost and many others. So we can say it as not a fully, but it is likely to be an ideal fuel, as it does not harm too much in the surroundings. But nowadays, CNG is also replaced by electricity. You can see electrical cars, electrical scooties, and many other. So we are taking steps to prevent these bad threats, and which is very good for our surroundings. So just think about it. And with this thought, let us end this video. Thank you and have a nice day.